Today we're going to talk about inscribed angles of circles. Now an inscribed angle is an angle formed by two chords with the vertex on the circle, shown in light blue. The intercepted arc, which will be important for our theorem, is the arc between the intersection of the sides of the inscribed angle, shown in pink. We have an inscribed angle theorem which says the measure of an inscribed angle is half the measure of the intercepted arc. So here we have 2x for the arc. That means the inscribed angle is x, half of it. So think about if this is 70, this is going to be 35. Now we know that a central angle is the same measure as its arc. So that means the central angle is 60, the arc is 60, which makes the inscribed angle 30. So we also know that an inscribed angle is half of the central angle. We have a couple corollaries that correspond with our inscribed angle theorem. The first one says two inscribed angles that intersect the same arc are congruent. So if you notice angle AQB in blue and angle APB in red, they both share the same arc of 132, meaning that their angles are both going to be 66 and they're going to be congruent. The second corollary says an angle inscribed in a semicircle is right. If we think about it, AC is our diameter. That means the intercepted arc is 180 degrees, making half of that 90. So any angle inscribed in a semicircle is going to be a right angle. The third corollary says the opposite angles of a quadrilateral inscribed in a circle are supplementary. So by the diagram, I can see B and D in light blue are going to add to 180. They're supplementary. So are A and C. Now we have another circle theorem we need to be aware of, and it says the measure of an angle formed by a tangent, remember a line that only touches at one point, and a chord is half the measure of the intercepted arc. So similar to an inscribed angle. So we look at our whole arc here, A, B, C. X is going to be half of the measure of that arc. So let's look at a couple of things. It says find the value of the variable. So in this one, it's going to be x, the angle x. And we know that it's a quadrilateral inside a circle, so the angles are supplementary. So 69 plus x is 180, or x is 111 degrees. And the second one, we're finding y. Y is a central angle, which means it's the same as the arc. Now I know that PQ is going to be twice as big as 62 degrees, or angle QRP, because it's an intercepted or inscribed angle. So twice 62 is 124. So that means the arc PQ is 124, which means the angle is going to be the same, 124 degrees. Find the value of P. Well, we know that angle C, or BCA, is going to be 90 degrees because it's inscribed in a semicircle. And we know a triangle adds up to 180. So angle A plus B plus C have to give me 180. So we know P we don't know. We know 90 and 55 gives me 145. So the leftover is going to be 35 degrees. And last but not least, angle X, or DXA. And it's hard to tell where that X is. We're not finding X, we're finding angle B. So if we look at this example, DXA and BXC are vertical angles, therefore they're congruent. So I know DXA is also 85 degrees. Now I know that angle that's 85 degrees plus angle D, which we know is 32, plus my angle A, which is what's represented by B, is 180 degrees. So when I add those all together, I get 117 plus B equals 180, and that's because it's a triangle. So B has to be 63 degrees. And that's it for inscribed angles. If you have any questions, please ask.